Uh, we stopped here last time. We're still talking about the casting. We stop here at this point, investment casting or lost wax process. Investment casting or lost wax process. The word investment casting, the word investment, if you look to the word investment, it means in English meaning making money, investment meaning making money. However, there are another word in the language, another meaning of investment in the language, which is the totally cover. The word investment here is coming like totally cover, not making money. So investment casting. So we call it investment casting or totally cover casting process. Another another name is the lost wax process. Lost wax, you know the wax which is اللي هو بالعربي يعني الشمع يا شباب. Lost wax يعني الشمع المفقود in Arabic. So the other name is the lost wax process. So we're using here, you can see that we're using wax here to do the casting process. So that's why we call it is a lost wax process. Okay, let's just go through about this investment casting. So investment casting meaning totally cover. The first step is to using the wax we create whatever we call it is a tree of pattern or pattern tree. This is a pattern tree. This is a product that you would like to produce, and this is a sparrow, and all made of wax. All made of wax. There are a very special machine to manufacturing the wax. So all made of wax, and then you create the pattern tree. This is a pattern tree, and this pattern tree made of wax. And then you bring the pattern tree, this one, and put in the solary. I mean, this is refractory material. Refractory material or solary of refractory material. So what is a refractory material? Many times we describe about the refractory material. So refractory material is a material can withstand high melting temperature or high temperature. So, or materials that have high melting temperature or can withstand higher temperature in casting. So this refractory material may be aluminum oxide, ceramic material, like for example aluminum oxide. We bring aluminum oxide as a powder and mix with a liquid like water, and then become like a paste, like عجينة يعني زي العجينة كده, like paste. And then you bring this kind of tree and put inside. Then that's why investment casting cup, which is a totally cover. Then we put several time, we put inside several time until it is totally covered. Actually, you may live in a while, you may live for a while in an environment so it becomes solid. The outer layer, this layer, the refractory material layer becomes solid, and then you bring again, if you would like to increase the thickness, you bring it back again to put inside, then you get increase of the layer thickness. When you reach the desired thickness, you leave it for a while to dry and then heat it. Heat it and invert it. Heat it. When you heat it, then this kind of layer, the refractory material layer becomes solid. Right? Then you invert it. When you heat it, then this layer will become solid, and wax here, the wax inside wax will spill out. You take it out, the wax will be moved out, leaving a hollow shell. This what we call is a hollow shell. And then next step, you bring this hollow shell. This hollow shell, you bring is a hollow shell made of refractory material, and then you put liquid inside. Definitely is a metal liquid inside. Then a metal liquid will replace the wax. That's why we call it is a lost wax. So lost wax here will be removed outside, and then you put metal inside to replace, and then finally you get a part made of metal. While solidification part will be ready, then you destroy. This is fragile. I mean, the shell here made of refractory material. This one is very fragile. If you hammer it, you can break it easily and you can remove it, and then you get the metal product. This is whatever we call is the investment casting or lost wax casting. Right. Again, initially we create the wax. Initially we create the wax pattern. This is a machine, as I told you. So like furnace, you pump here wax liquid. This is a wax liquid. You pump wax liquid here, then fill cavity, so you can manufacturing the parts. Then you manufacturing the part, and then you assemble with the spiro, also made of wax. Then you get tree, the pattern tree. Then you bring the pattern tree and totally cover in refractory material, then totally cover with the refractory material, then it totally cover, then you invert it as you can see here, and you heat it. You invert it and heat it. When you heat it, you get a solid layer of refractory material, and the wax will be removed out. Wax will be removed out, that's why we call it the lost wax, will be removed out, and remaining is a hollow shell or hollow hard shell made of refractory material. Then you put liquid inside, then you destroy this kind of solid layer of refractory material, then you cut parts, then you cut, you get the parts that you would like to have at the end of the day. Again, this is make it closer. This is a tree. This is a wax tree. This is a wax tree or the pattern tree. Here you put in the refractory material, totally cover. You remove the wax, you put liquid inside. This is a metal product that you obtain at the end of the process. Right. Okay, let me show you something to make it easy for you to understand. Let me show you something. Right. Okay, so from beginning again. This is dye to be used. This is a wax, liquid wax. They melt wax, they pump in the dye, and then they manufacturing the part. This is a part made of wax. This is a part made of wax. This is the first step. Second step is, or third step, this is to assemble the wax in a spiro. This spiro also made of wax. So all made of wax. You get the tree, then you bring the tree, you put in a slurry. This is a refractory material. Then you put several times until all totally cover. Until totally cover. Several times. Then totally cover with refractory material. You invert it. Now you invert it, and then you heat it. This is a but in a furnace or something. You heat it. Then wax will be removed, as you can see, and then you get a hard layer of the refractory material, hollow shell of refractory material. Then you heat it more to dry it and become dry. Then when it become dry enough, you can use this one as a mold. Now this is a mold. We manufacturing mold of refractory material. Then you put this is a liquid metal. The liquid metal will fill this kind of shell or hollow shell made of refractory material. Finally, while solidification, the part becomes solidified and liquid inside. Then you destroy. It is fragile. Destroy this layer, the outer layer. You destroy. Then you get the product. Then you cut. Next step to cut. This is a parts. This is a parts made of metal. So this is a way how to use this one. Okay, let me show you another. Let me show you another file. Let me show you another file to describe this one, another video. Actually, this is nice video to show you. Okay. This one I show you previously. This one I show you previously, which is describing the casting process. This is previously we discussed about the cup and drag. This is the sand casting cup and drag. I believe you. I hope you remember this one. This is a pattern, and then you put a pattern in the. This is a flask. This is the sand. Then now creating the mold, and then as I told you, this is cup bison. This is sparrow. This is a runner. This is a gate. This is the main cavity, and so on. So this is a sand casting, ordinary sand casting process. This is here feeding in a sand casting. This one described about the sand casting. Now this is lost wax investment casting. Next is the investment casting. This is a shell actually. This is a shell made of refractory material and then they put liquid. Now they're going to describe how they doing this one from beginning to the end. This is a wax. This is a wax. This is a tree of wax. This is a tree of wax. Tree made of wax. There's a part probably they would like to produce, and this is a final product. This is a wax. There are a machine here to manufacturing the part made of wax, as you can see. Then they heating it, they make it, then they put wax. They assemble now. They assemble the wax part. This is several parts, as you can see. One by one, they heat here, cup. And this is a tree of wax. This is a pattern, tree pattern. They put here in the solar. This is a solar actually. This is a refractory material, totally cover and put powder, more powder, so totally cover refractory. Then you see again, put again, put again, put again until totally cover with the refractory material, and then invert it and put in a furnace. Put in a furnace so you dry it. Then it is very hot, as you can see. You bring it here. They break it. It is shallow now. It is remove the wax, remove, and now put liquid inside. This is a liquid in a shell. Directly put in liquid, and finally, also solidify, destroy the outer refractory material. Then you get part made of metal. Now they put liquid in the shell. This is the refractory material, and then they close to stop, to remove the air, and then fire stop, and then getting cooled down to solidify, and then you remove this one and destroy. This is a different product made by using investment casting. So this what we call is invest casting. This is a lost foam actually casting that we described earlier. They put foam inside and they put liquid in the foam. This one actually we described earlier. Okay, get back to slide again. So totally cover, investment casting totally cover. This is a tree of wax, and then put totally cover with refractory material. They invert it, they heat it, they remove the wax, and then become this one solid. Put liquid inside, and then you get, while solidification, you get the product. You destroy the shell, then you get a part. You get a part made of metal, or the metal product. This whatever we call investment casting or lost wax casting. Any question? Is it clear? Right, advantages part of great complexity, very complex part can be produced. It's kind of improvement if you can realize that this is another, still we're talking about expandable mold casting. Still we talking about expandable mold casting. Expandable mold was sand casting as a beginning, but it's kind of improvement about the expandable mold that we are, whatever we call, sacrificing the mold, destroying the mold. So advantages is a part of great complexity, and originality can be casted, close dimension control, and good surface finish can be obtained. Wax can be reused or recycle. Additional machining probably not required in this case. Disadvantages, many process steps required, as you can see here, relatively expensive process compared with the sand casting. This is the investment casting. Also another improvement with whatever we call is expandable mold casting is to make the mold of plaster. make the mold of plaster, made of plaster, the mold made of plaster. Now we're going to use a plaster to manufacturing the mold. Previously, we were using what we call is a sand to manufacturing the mold, but sand casting or sand mold or the mold made of sand. There are many issues. Yes, sand is free, and this one is the cheapest to manufacturing, but it's kind of improvement. People try to do improvement to obtain better quality product, faster production rate, and so on. So plaster mold casting, it's a way of improvement in expandable mold. They call it also open and cup and drag investment casting, cup and drag investment casting, mold made of plaster, mold made of plaster which is a gypsum. Do you know the gypsum؟ الجبس يا شباب، gypsum اللي هو الجبس اللي هو بنسميه احنا الكالسيوم سلفيت. This gyps we're going to use the gypsum to manufacturing the mold. You know, gypsum is a material can withstand high temperature or having high melting temperatures. This gypsum being used in manufacturing the mold. Let me show you or share with you a video to show you about this plaster mold casting. Okay. Actually, this is a mold. We would like to manufacturing gypsum. This one made of metal. It's a pattern. This is a pattern made of metal. This is a different pattern made of metal. And this is a gypsum. They bring gypsum and put a gypsum in a pattern or put a pattern in a gypsum to manufacturing the mold. Now we would like to manufacturing the mold. And now when you leave the gypsum in the room temperature it solidify. جبس يا شباب اللي بيستخدموه يعني في المباني لما if you leave it in a room temperature it will solidify. So this is the core. This is the core. This is a core made of gypsum. And this is assemble the core. This is a mold made of gypsum. Here several mold. Like going to use this one to make the casting. This is a core. This is a core. Its internal dimension they would like to have. They assemble together with a mold. Okay, these are a cup and drag. There are a cup and drag. They now going to assemble. Now they spread some oil, some parting agent to facilitate removing the material from this one. And this is a cup and drag. Cup and drag. Here the assemble cup and drag, then cavity will be created. This is the cup. This is the drag. They assemble cup and drag together. Then mold is ready. This is a liquid metal. They're going to cast in here. This is a mold made of gypsum, and this is a here sparrow. They put inside. Liquid will move up from the other side. They can realize that it is totally filled with the liquid. This is a part being produced. Later they remove from the gypsum. They destroy the gypsum. Gypsum is easy to destroy. It is kind of, this is a part being produced by this kind of method. It's kind of improvement, as I told you, from sand casting process. It is other expandable mold casting process. It is other expandable mold casting process. We call it is the gypsum mold casting, right? Okay, go back to the slide again. Okay, this is a plaster mold casting. Plaster mold casting, then we manufacturing. This is a pattern. This is a pattern. We have a pattern as you can see. This is a gypsum or plaster. They bring the plaster here to cover here to be used to create the mold. So we create the mold or make the mold made of plaster or gypsum or calcium sulfate, and then using this one as a mold cup, we create a manufacturing cup and drag. and put liquid inside. Low permeability and metal poured in vacuum or pressure and good surface finish can be obtained. Close, showy, and low conductivity, uniform grain structure can be also obtained. This is the plaster mold casting. Ceramic mold casting is very similar. Ceramic mold casting is very similar to plaster mold casting. The only difference between plaster mold casting and ceramic mold casting is the material that you use to manufacturing the mold. Previously, we use a plaster to manufacturing the mold. Here, we use ceramic. So same way, but you use ceramic material. What ceramic material? As I told you, could be aluminum oxide. You bring aluminum oxide as a powder, and then you put a liquid, then become like slurry, and then you bring this one and drop it here. This is a pattern when you put inside, you leave in the room temperature, it solidify, become solid. You manufacture in cup and drag, and then you fire it. Fire it means you dry it to make it hard. Then you use it as a cup and drag. You can use in the casting process. Later, after casting, you destroy the mold and take part out. This is another way of the expandable mold casting, or another technique in another a modification in expandable mold casting. Finally, regarding expandable mold casting, which is whatever we call is a vacuum molding. Vacuum molding is also another process being used in industry. And here in vacuum molding process, we manufacturing also cup and drag. This is a mold. This is a mold made of sand actually, mold made of sand. But it is sand with whatever we call is the urethane. Urethane is a binder, very good binder material mixed with the sand, become hard. Then sand, when you mix with this material, is become hard. They molded over metal dies. Then we manufacturing this one over a pattern. There are a pattern. We put the sand in a pattern to manufacturing this one, right? Then we manufacturing this one, it become hard, and this one cured with the amine vapor. Amine vapor, when you have amine vapor, this one become a hard skin. Then we using this one as mold. This is the cup and drag, and this one is especially vented. Especially vented, we create many vent or tiny holes here. The manufacturing here very tiny holes to apply vacuum pressure. They drop this one in the liquid. They drop this one in the liquid metal, and then they apply negative pressure. Then there are a very tiny hole here to allow vacuum pressure to suck liquid from the from the furnace to fill all cavity in the mold, and finally you obtain the part produced. You destroy the sand and finally obtain the product. It's somehow complicated, but also still being used actually. So cup and drag. This is a cup and drag with tiny holes. There are tiny holes here to enable vacuum suction. As you can see, there are a vacuum pressure being used, negative pressure being used to bring liquid inside the mold, and then this one can be used as a expandable mold process. Later you destroy the mold and take the part out. This is a vacuum molding process. Advantages: easy recover the sand. I mean, sand can be used several times. Sand does not require mechanical reconditioning or manufacturing. Easy to be used since no water mixing, because using urethane and amine vapor, the moisture related defects are avoided. There are no gases, there are no bubbles, no cavity, no porosity, and so on. This advantage is very slow and complicated, and also expensive, and not actually cannot be used in automation system or mass production system. Okay, this is the end of the whatever we call is the expandable molding process. So now we just finished expandable mold process. Next, we're going to discuss about the permanent mold process. Next, we're going to talk about the permanent mold process. Permanent mold process, what is a permanent? Now expandable and permanent. Expandable mold process that we're going to use molds that we can sacrifice, we can destroy and take the part out. Permanent mold is opposite. Then permanent mold we're going to use to manufacturing mold to be used in several times. This is a big difference between the expandable mold and permanent mold. Now we're going to discuss about the permanent mold processes. Where the processes include the basic permanent mold casting, die casting certificates. This is the items that we got going to cover in the permanent mold. Let's see one by one. This is a basic permanent mold. The basic permanent mold actually, as I told you, the mold now will be used for several times. Mold made of metal. So use metal mold construct of two-section design for easy, precise opening and close. It is two-part usually. The mold made of metal, not made of sand, not made of expandable mold process or refractory material or whatever materials that we can sacrifice and destroy, but made of metal. Made of metal, right? Probably steel or cast iron. So the mold made of metal, and mold made as two parts. Mold made as two parts, metal and two parts. These two parts for to close and open, because when you close you get the cavity inside, when you open you take part out. Then you close you get the cavity inside, when you open you take the part out, and so on. So it made of two parts. Then this is the basic permanent mold, general basic about the permanent mold. No specific details, but general basic information about the permanent mold. Mold use casting lower melting temperature. This kind of mold must be used in casting lower melting temperature material. Definitely, if you have same liquid, steel can cast aluminum. You must cast the liquid inside, have a lower melting temperature. For example, if you use here mold of steel, then you're casting aluminum, you're casting brass, you're casting whatever lead or whatever other material, but you cannot cast steel in steel. If you try to cast steel in steel, what will happen? Then destroy the mold, because have same melting temperature, you put steel liquid in the steel, then you destroy the mold. The mold used to casting lower melting point, alloy or material, and these are made commonly from steel or cast iron. A mold made of steel, usually steel or cast iron. Mold used for casting steel must be made of refractory material. If you would like to cast steel, you cannot use mold made of steel, but you have to use mold made of higher melting temperature like refractory material to manufacturing or to cast steel. Then this is the two part. You close, you get the cavity, you put the liquid inside, you leave it for solidification. When it solidify, you open, you take the part out, and so on. Right? This is a permanent mold. Steps in a permanent mold. Steps. There are several steps in a permanent mold. First step is the mold is preheated. Now still we didn't do anything yet. We're preparing the mold for the casting. The mold here, this is made of metal or made of steel, is preheated and coating for lubrication and heat dissipation. This is lubrication. We put oil inside. Why we put oil inside? This is very important actually. It's preheated and we put oil inside because when you put oil inside, this oil will facilitate removing the part later when you do the casting process. This is the stationary part. Stationary meaning fixed, not moving. This is a moving part and connected with the system to open and close. Hydraulic, maybe pneumatic or hydraulic system to open and close. This is the first step. Second step, you close. You close. This part will be moved to close. When you close the mold, you will get the cavity inside. You will get the cavity inside. Right? Maybe there are a core, maybe you can use core, or maybe you not use core. It depends on the case by case. Then when you close, you get cavity inside. When you get cavity inside, third step, you put liquid. Then liquid will fill all cavity inside. Then you leave it for solidification. After solidification, you open and then you take the part out. This is step in the mold. Here this photo to show you they put liquid in the permanent mold. This is the permanent mold. So this is the steps in a permanent mold, right? Okay, let me show you something. Let me show you something. All right, just give me a second. Okay, it seems like layer is not okay. Yeah, please stay remaining. I will close and open again because this one is need to reclose and open again. Just stay, remain. I'm coming back again very soon. Started. Okay, let me show you this video to describe about the permanent mold, right? Okay, let me bring it back again. This is a permanent mold actually. Actually, this is a mold made of metal. This is a permanent mold. This is general. We talk generally about the permanent mold. This is a permanent mold made of metal. Can you see that? Then now they put a core. This is a core. Let me show you again. Sorry. This is a core. They put core inside. They put core inside. Then this is a core. And then they put liquid here. This is a liquid. And solidify already finished. They take core out. Remove. This is, you see that the core create hole inside. This is a core. This is a body liquid. Now it's finished. Then open. This removing the core. Now open. This is a liquid. We put liquid here. So you can see that it is hollow because core is inside. So this is generally permanent mold. It's very fast as you can see. Very, very fast. Fracture of second. Okay. Get back again to the slides. So this is generally about the steps of the permanent mold. Steps of the permanent mold. As we described, you open, you oil, and then you close. You get the cavity. You put liquid inside. When you solidify, you open, take part. Probably core will be assembled and consider core while you are assembling here. Advantage and the limitation. We talk generally now. Advantages and the limitation. Advantages is good dimension control and surface finish. rapid solidification. You can see that very quickly cold in very quickly, very short time. Rapid solidification caused by metal mold resulting in finer grain structure and uh, casting become having good mechanical properties actually. Moreover, actually, we can add it here cooling cycle. This is, you can just leave it because this made of metal mean heat, a high heat transfer rate, then cooling will be very fast. You can add it also cooling channel here, and you can pass liquid inside, like cooling liquid like water or something, to absorb heat quickly, then make time shorter actually. So you can control not only rapid cooling or solidification, but also you can increase the rate, or you can make it faster by adding cooling channel inside and circulate liquid water and so on. So you can control the time. When you're controlling time, solidification time will be reduced, and then this one will result in finer grain structure and make better mechanical properties. Limitation, generally limited to metal of lower melting temperature. When you casting material, you must cast material in cast lower melting temperature material in a mold. You cannot mix same. So this is one limitation. Simple geometry can be obtained here because, as I told you here, you have to facilitate the motion of the part at the end of the process. If it is complicated, it will be very difficult to remove the part. Then you have to design this one for, I mean, simplest or simpler geometry. If you need a complex or very complex, then you have to go to expandable mold cast. No way, no way. You have to go to expandable mold cast. But here in a permanent mold, usually simplest process can be done here, or simplest geometry can be done here in a permanent cast. However, in a permanent mold cast, this one is more expensive because you're manufacturing the mold. This mold is costing money, so it is usually, or generally, is this one costing more than in the sand mold casting. Application of metal of permanent mold due to the mold cost process usually justified for mass production. This one generally being used, or the main advantages of the permanent mold is to be used with the mass production. Mass production means to manufacturing many product. Typical part, automotive, piston, pumps, and many actually. Material or metal to commonly cast as a permanent mold: aluminium, magnesium, copper-based alloys, cast iron. This one not suitable for steel casting because very high boiling temperature. However, still you can cast steel in a permanent mold, but it's requiring maybe refractory material to manufacturing the mold. We have whatever we call semi-permanent mold casting. Semi-permanent mold casting. What is a semi-permanent mold casting? Semi-permanent mold casting, actually, it is a permanent mold. Ordinary, as you can see here, it is very similar as we described earlier. Very similar. The only difference between the permanent and semi-permanent is the core here. In this case, this one made of metal, but the core made of sand. Core made of sand. Someone will ask me why? Why we have to use core made of sand? Why you just simply make core or manufacturing core made of metal as also same material as a mold? Because here when you use a core, actually when you put liquid inside, liquid fill all the cavity, while solidification, this kind of metal would like to shrink. The hole here would like to shrink. This hole would like to shrink يعني ينكمش. This area would like to shrink. If you make made of metal, it's very difficult to take the core out. I prefer to make the core made of sand. Some cases, but also metal can also. Then, but easier to make of sand. Then when this one shrink, this one made of sand. Later, when you take the part out, simply you destroy, take the part easily. Especially when the core is inside. When the core is located inside the mold, so it's preferred to made of sand. In this case, we call it a semi-permanent mold. So semi-permanent mold, the core made of expandable material or made of sand, right? Die casting. First process we're going to discuss in a permanent mold is a die casting. They call it is a die casting. In a die casting process, we have two main type. In die casting machine or die casting process, we have two main type: hot chamber and cold chamber casting. Hot chamber and cold chamber casting. Actually, they called it hot chamber because the chamber here, as you can see, this is a chamber. This is a chamber. Can you see that? This is a chamber. Chamber here is fully immersed in a liquid. This is a furnace. This is a liquid metal. This is a liquid metal. The chamber is totally immersed in a liquid metal. That's why they call it hot chamber. All time this chamber located or immersed in the يعني الشامبر دي يا شباب طول الوقت هي جوه الليكويد located in the liquid. So that's why they call it is a hot chamber. This is a plunger. This plunger or piston move up. When it move up, liquid will fill all cavity here. Then plunger move down to push the liquid, to force liquid to move in a cavity here. This is a mold. This is a mold. This is a stationary mold. This is the open mold. This is to open. This is a system to open and close. Then open and close to get the cavity. Then open to take the part out and close to get the cavity. Here you push the liquid will move and fill all cavity here in the mold. So this whatever we call is a hot chamber. Okay, the pressure being used here is a plunger here applying pressure, plunger here applying pressure. To apply pressure, the pressure will force liquid to move to fill the cavity. Actually, when a plunger apply pressure, initially apply pressure and then also maintain pressure. Maintain the pressure until material totally solidify here. When the plunger maintain a pressure, then this one ensures that liquid will feeding inside, and then while solidification and shrinkage, more liquid can be supplied to compensate shrinkage happen in a mold cavity or in the mold on the main cast part. So this is very good way actually. So this is producing very good quality, very good surface quality, material properties and mechanical properties of the product is excellent, and also dimensional accuracy it actually is very good. Dimensional accuracy here is very good because pressure apply, we apply pressure all time until totally solidify. So while shrinkage, this area still liquid remaining can push here. There are no riser here, but the liquid can be supplied under pressure to maintain. So if this one solidify, because here heat transfer rate here is very high, and we can also circulate liquid around to increase heat transfer rate, then solidification happen very quickly. Then this one is still remaining liquid. Then if solidification happen here very quickly and shrinkage happen, you can supply liquid this under pressure, then liquid can be supplied again to compensate. Then finally you produce or finally you get a very good or excellent dimensional accuracy compared with the expandable mold process as we described earlier in the expandable mold process. And here low melting point alloy such as material can be casted here in a hot chamber is a low melting temperature material like zinc, tin, lead is a material can be casted with a hot chamber here. Because the chamber all time located in the liquid, you cannot melt, you cannot actually cast a higher melting temperature, otherwise you destroy the chamber. Cycle time range actually is 900 shot per hour. 900 shot meaning 900 product per hour, piece per hour can be produced. How many per minute? You divide by 60 mean 90 by 6. 90 by 6, almost one and a half part in second. You see, it is very fast process. A cooling rate is very high and very fast process. We can reach up to this level. Very small components such as zipper teeth, I mean this one filling teeth is can be produced, and dyes are cooled by circulating water or oil. They actually, as I told you here, this is a channel. They put channel around here. There are a channel here. They put channel here to circulating liquid, whatever, maybe water, maybe oil, circulating with water inside or liquid inside to increase the heat transfer rate, shortening the time, solidification time. So it can, I mean, quickly mass production. It can be used for mass production. Okay, this is a hot chamber. Chamber here located in the liquid. Chamber here located in the liquid. The plunger is move up, then open. Liquid will get inside. The plunger push liquid, then liquid will move. Under pressure, liquid will move to fill the cavity here. Liquid will move to fill the cavity. This is the first step. Plunger is open. Liquid fills the cavity in the chamber. Second, plunger is pushed down. Plunger moving down, apply pressure, push the liquid will move and fill all the cavity inside. Still remaining, you apply, still applying pressure until this one solidifies. There are a liquid here, circulation of liquid. They quickly would solidify and then pressure release, and then open and takes the part out. This is a hot chamber. Okay, let me share with you something to show you about the hot chamber. Okay, let me start again from beginning. This is a hot chamber. You see that plunger pushing liquid, the liquid will move to fill all the cavity. You open, you take the part out. This is the ejector pin to move the part out. And now this is the moving part, this is the stationary part. Then this one you spread oil. Initially you spread oil as I told, then you close, then you get a cavity here. Then this is the cavity you get when you close, you get the cavity. This is a chamber actually. Chamber immersed in the liquid. This is a liquid, the chamber is open, liquid filling all cavity inside. Then now system is ready and the cavity is here. Then plunger will move down. Plunger will move down, push liquid to fill all cavity here. While solidification becomes solid, you open, you take the part out. You take the part. This is the ejector pin. We call ejector pin to push this one out. And then you spread oil, and then you close, you get the cavity. Plunger will push liquid again, then liquid will fill. While solidification part will be ready, you open, you take the part out, and so on. So this one repeated, as you can see, several times. Right. This is a hot chamber. This is a hot chamber. Get back to the slide again. Okay, this is the hot chamber as I told you. Plunger is open now, liquid will get inside. Next is the plunger moving down. Plunger move down to push the liquid to fill all the cavities. Solidification, you open, it takes a part out, and so on. This is the hot chamber. Next is a cold chamber. Next is a cold chamber. And the cold chamber, the difference between a hot chamber and cold chamber is that the chamber is in air, not in a liquid, not immersed in a liquid. When you feeding liquid manually, you feeding liquid manually as you can see here. So this is a liquid, you're feeding liquid manually and then you pump liquid to fill all the cavity. You can see that, you can realize that it is very similar to hot chamber. The only difference is that chamber, we call it cold. It is very hot actually, but it is in air, not immersed in liquid. That's why they call it is a cold chamber and liquid will be filled manually. Right? So this is a big difference between the hot chamber and cold chamber. Actually, time is now just finished and we have to stop here. And next time, inshallah, continue discussing about the cold chamber. Let me stop